All right, so the last unit we did was sequences and series. We lived in the land of geometric for most of it, but you should know the word arithmetic. Arithmetic means what am I doing to get to the next term? Adding. So if I have these being arithmetic, it goes 12, 16, mystery number 24. What would my mystery number be? Would be 20. What if it was 10? Oh, this is not a good one. I think the 0 is supposed to be a -5. 10, 5, mystery number, -5. It will be a 0. That was an oops-a-doodle. We understand the idea of arithmetic. Now, geometric is similar, but what am I doing to get from term to term in geometric? Multiplying. So 2, 6, mystery number 54. What are we multiplying by each time there? 3. So my mystery number would be 18. 24, 12, mystery number 3. 6. What are we technically multiplying by there? 1/2. Now, a reminder, to get your common ratio, you can take any term and divide it by the 1 in front of it. So if I, in my top one, wanted to get that, I could take 18 divided by 6. I could take 6 divided by 2. They all would work out the same. The ratio was a 3. So if you can't see it right away, you take any term, divide by the 1 in front. For B, I know the ratio would be a 12 divided by 24, or I found the mystery number, but 6 divided by 12. Would you agree all of those simplify to give you a ratio of 1/2? So as much as you are dividing by 2, it is the same as multiplying by 1/2. So far, so good. So if I gave you something like this, thinking about the idea of the common ratio, first 3 terms are t, t plus 2, and t plus 4. Algebraically determine the value of t. What do I know here? I know the first 3 terms. What do they have in common? They have t's in common. Would you agree to get from one to the other thing in common is the common ratio? So to get from the first term to the second term, could I say that the common ratio is t plus 2 over t? Or to get from the second term to the third term, the common ratio is? Good, t plus 4 over t plus 2. Now, yeah, I get you maybe don't like the t's. If you want to change it to x, you change it to x. Looking at this, the thing that is the same for both is the r, agreed? So this is just substitution. What they're saying is if r in the first one is equal to t plus 2 over t, could I sub that in for the r in the second one? And what I would end up with is t plus 2 over t equals t plus 4 over t plus 2. This is a rational equation. I'd like to get rid of the denominator, agreed? I need a common denominator. What would the common denominator be? Good. T times t plus 2. Now, the first piece had the t in the denominator. If I multiply it by t plus 2, but I have a binomial in the numerator, what do I have to remember to do? I have to FOIL it. So t plus 2 times t plus 2 is going to give me t squared plus 4t plus 4. My second expression, which is on the right side of the equal sign, had the t plus 2 in the denominator. What did it need to get multiplied by? T. That's going to give me t squared plus 4t. Now the denominator is the same. Would you agree at this stage I could eliminate the denominator? So I would keep my numerators. Maybe I write them out, t squared plus 4t plus 4 equals t squared plus 4t. Ooh, did I pick bad numbers maybe? Yeah, because normally what we would do, would you agree we would cancel out our t squareds? And I'd get 4t plus 4 equals 4t. Is that possible to solve? No. But if it was possible to solve, would you be able to solve it from there? I'll fix the numbers for next semester. Okay, moving on. Obviously, it's not my day. What if I say infinite series and I say calculate the sum to infinity? Yeah, sum to infinity or S infinity, and it will be on your formula sheet, equals T1 divided by 1 minus R. But sometimes you're not allowed to. Would you agree this is the whole idea of convergent or divergent? What were the two cutoffs? -1 and 1. If R was in between -1 and +1, what did we call that? Convergent. That starts with what letter? If it is convergent and it starts with C, can we use the formula? Yes, C is can. On the outside is the other version. It is divergent. If it is divergent, it says don't. Now, those are not mathematical terms, my friends. Those are just ways that Mrs. Brown remembers it. You can remember it your own way as long as you remember it. So when I look at my first one, I would take perhaps 6 divided by 3. 6 is the second term, 3 is the first term. It tells me the common ratio is 2. Can I calculate the sum of this? No. No formula. This one is divergent. Let's see if I picked better numbers for the second one. If I go to calculate the common ratio, I could take any term. 8 divided by 16 tells me this is 1/2. Can I calculate the sum for this one? Yes. Sum to infinity is equal to T1 divided by 1 minus R. Jeff, what is the first term of this one? 16. 16 divided by 1, take away 1/2. I would probably do my denominator first. It would give me a 1/2. 16 divided by 1/2 tells me that the approached sum, but not the real sum because it's not actually ever going to get there, is 32. So a quick little refresher on some of the key points coming out of that unit. Ringing a bell? Now this one I don't have a full booklet for, but the AVP has a great practice test. So you can go to the practice test. And in fact, if you were thinking that as we went through today's lessons, it's going to be some of the trickier ones that might get you and you want extra practice with them, are the AVP practice tests a great place to go. They have the questions that take it that extra level.